Here we have an EVGA graphics card that came in for repair, and the customer mailed over the PCB only, like this, and not the whole card. No heatsink, no housing, nothing. That's okay. However, on some video cards, we have to have the heatsink and fan connected in order to see an output or in order to test the card. Customer wrote, in the title of the ticket, he wrote, video card lost output while gaming. And which card is this? This one is the EVGA GeForce RTX 3090 XC3 Ultra Hybrid Gaming 24G-P5-3978-KR. The customer wrote, teenage son was playing and said the screen just went blank. He took the card out, cleaned it, and applied new paste to the GPU, which of course did nothing. Card was in a custom water-cooled loop, so it will be sent in bare PCB, which is what we have now. I was able to determine F6-502 was blown, but beyond that, I'm of no help. Referral source is YouTube subscriber. The customer has enough knowledge to know that he has a blown F6-502 fuse. That's amazing. It means the customer is watching and learning, and he's comfortable enough to test the board in a way where he was able to figure out that we have a blown fuse. Let's take a look at the board. Focus the microscope. This amazing microscope. We carry and sell the microscope. We have the red version now. We carry everything from soldering stations, hot air stations, this amazing microscope, the articulating arm, anti-glare light, and I think we may be out of stock on the anti-glare light, but we have a shipment coming in. It may take a month. It comes by sea because those anti-glare lights are heavy, very heavy. But just log into NorthridgeFix.com, click on shop, add whatever you want to cart if we have it in stock, check out, pay, and we almost always ship out same day. If you look at the card here, we have two connectors, two 8-pin connectors. So we have 12 volts going in through the fuse, current sense, coil, and the second connector, we have another fuse, which the customer said is blown, current sense, and coil. Now, I did not check to verify that we have a blown fuse. I'm just taking the customer's word for it because it looked like he knew what he was talking about. And he's a watcher of the channel. I trust him. We're going to measure in diode mode. Measuring in diode mode, we can hit two birds with one stone. We can tell if the fuse is blown and also if we have a short circuit. So let's measure the right side of the fuse, and I'm reading 1.09 voltage drop, and we should read the same on the left if that fuse is continuous. So we know that we have a short circuit and we know that we have a blown fuse. We hit two birds with one stone. Now the fuse is not going to blow on its own. There's something else on the board that caused that fuse to blow. And since we have a 12-volt short, it's very likely that we have a faulty DrMOS, whether it's one of those BLN0 DR MOSFETs or the AL00 MOSFETs. Right there, AL00, 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 and AL00. And look at this. Look at this one. Look at what I see here. Or maybe I see nothing, but it may be nothing. Maybe this DrMOS suffered a lot of heat, and that's why the joints, they look a bit off, because if you look at the joints here, they all look the same, and they look perfect. If you look at this one, they all look the same. They look perfect. Same here, same here, same here. But look at the first one. They do not look good. You see how we have like a tiny bit of solder that came off? So that tells me that this DrMOS suffered a lot of stress. Same here. Look at the joints on the side here. Look at this, how it looks perfect. Looks perfect. Perfect. But this one does not. So just based on visual inspection, I'm able to tell that maybe we have a problem with this DrMOS. Now on Gigabyte cards, I kind of detected a pattern. Anytime we have a short circuit on the 12-volt line, it's usually the next MOSFET after BLN0. So we have all BLN0s on the bottom. And right after BLN0, we have AL00. Usually that's the culprit on Gigabyte cards. But it can really be any one of those DR MOSFETs. And we have more on the left side. So we have a set of DrMOSs here and here, but I do not believe that we have a short circuit on the PCIe slot. Let's measure for the 12-volt short on the bottom here. We do not have a short. I'm reading 0.5 voltage drop. And if we measure our 3.3 volts, I'm reading 0.475. So we are good at the slot. We're going to put that rubber piece back, because that rubber piece is holy to card owners. They like to keep it. Now for this card, I think I'm going to go with my instinct. We're not going to use voltage injection or a thermal camera, because to me, it's very obvious that we have a problem with this DrMOS. That's the bad guy right here. I would say 90% chance that we have a problem with this guy right here. So let's do something different without using a thermal camera. Let's see if we are right. One thing we have to watch out for is this plastic connector. The connector is very close to this DrMOS, and we're going to have to apply a lot of heat here on this DrMOS to desolder it. So we have to watch out. We do not want to burn this connector. If it burns just a tiny bit, that's okay, but we do not want to completely deform that connector, otherwise we're going to have to replace it. So right now there is no easy way to prevent this connector from burning. All we can do is separate that connector with a shield and hope that we do not get any hot air onto that connector. Maybe we can have something like this shield here. We can go like this, and I'm going to apply hot air right here. So what I did is I rolled up a Captain tape, sticky on the outside, sticky on the outside. I put one in the front and one in the back, and we should be good. Just like that, you see? I separated the connector and the caps from the DR MOSFETs. Art. Take a picture and hang it on the wall. Now what's happening is heat is bouncing off that plate and coming back at my fingers. But it's all right. We can burn 2 fingers, no problem. I have 10. As long as we desolder this MOSFET. 2 fingers, no problem. Ouch, ouch. I smell burned hair. But that's okay. That's why we get paid a lot. Because we suffer in the process. I need to put a metal plate under the card because my mat got some heat through that hole and it bubbled up. Nice. The chip is out, and if we check the connector and the caps, they are safe. They are hiding under mommy's arms. We have Captain tape and we have that Great Wall of China. That DrMOS is in a very delicate area of the board, but what can you do? And I think we applied solder everywhere. Nice. Anti-glare light. Beautiful. Just want to make sure that we have enough solder on all the pins or all the pads. And we're good. It's very awkward working on this card. I barely have any room between this inductor and the shield. Barely any room. Now I do not have any of the AL00 in stock, so we're gonna grab it from a Gigabyte card until we get them back in stock. I'm gonna heat the board until I see solder liquefy. Then I'm gonna put the chip on the board. Once I see that center big blob liquefy, I know that we're good. Right there. See it? And now we're gonna put that chip right there, just like that. Look at the precision. Let's go here and check if we still have a short. We have 1.5 voltage drop and we have 0.3 voltage drop. See? We have 0.3 because we do not have a short anymore. The short is gone. So our guess was right. That the DrMOS did not look good. I took a guess, removed it, replaced it, and now we checked for a short and we do not have a short. But now we're gonna have to replace the fuse because the fuse is not good. Look at how I burned my finger. I told you that I'm gonna burn 2 fingers. That's one of them. And that's the other one. Part of the job. We're gonna have to charge the customer 50% more just for my injuries. I'm just joking. Some people will take it serious, some viewers. And I mentioned this many times before. I joke on something and people take it serious. Really? Are you gonna charge the customer because you burned your fingers? And we're done. We're gonna use Amtech wipes to take out any residue of flux that's left on the board. And look at how nice the board looks now. If you are a hobbyist or in the same type of business and you do not already have Amtech wipes, you know where to buy them from. Just log into our site, add to cart, checkout, pay, and we'll ship out your package almost always same day. You already know by now. Now we're gonna test the cord. Plug it in right here. And now we're gonna plug 2 power connectors. That's one of them. And we have another one right here. We're gonna monitor this monitor, or we're gonna look at this monitor, and we'll see if we're gonna get any output on the screen. Turn the power supply on. Fan is spinning on the power supply. And let's take a look at this monitor right here. We do see the light, but unfortunately we are getting 6 beeps, and 6 beeps is an indication that the card is not working. Anytime we have a short circuit on a 12-volt line, we have a blown fuse and a faulty DrMOS, it's very likely that the GPU may get affected, may receive higher voltage than what it can handle, and it fries itself out. I mentioned it many times before. Replacing the DrMOS and the fuse may fix the problem, or may deem the card a no fix if it doesn't fix the problem. What I want to do is measure for voltages. Let's measure for the first 12-volt rail. and we have 12 volts. Measure the second one. We have 12 volts. 5 volts. Do we have it? We do. 5 volts. Measure our 1.8 volt line. We have 1.8. If we measure memory, I think we're not going to have memory and vCore because the card has been on for a while. Let me just start fresh. Turn on the power supply. And we're going to measure memory. And we have it, 1.39. And if we measure vCore, 0.75. 1.8, 1.37. We have everything. We have it all. I'm gonna put the card on the side. I'll go over it tomorrow. It's getting late. I worked long hours today, fixed a lot of devices, and I'll start with fresh brains and see if I can figure anything out. But honestly, I think there's a good chance that we're gonna deem this card a no fix. Like I said, anytime we have a 12 volt short, we have a blown fuse, we have a faulty DrMOS, there's always a chance that the GPU may receive higher voltage than what it can handle, and it fries itself. I checked the board, visual inspection, did not see anything obvious. So as of now, the board may be deemed a no fix, but I'm gonna give it one more chance tomorrow and send it back to the customer. Let me know what you think, leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.